So hello everyone. In this particular session, we'll be learning a simple XOR trick in order to swap the contents of any two registers. So first, we will see if this trick actually works. After that, we'll try to understand why exactly it works. Okay? In assembly, if you want to perform XOR operation, then the instruction you will use is EOR, or in other words, bitwise exclusive OR. What's the truth table of this particular operation? If you consider any two bit positions A1, B1 and Y being the output, if XOR operation is performed, output will be 1 only if the inputs are complementary to each other, while it remains at 0 if you have same values. Okay, this is something you should know before proceeding with this code. First of all, let's see if there are any errors in this code. Okay, before executing the code, let's see what's written over here. Area is an assembler directive which defines a specific section of memory to store this particular code. It is code here because this is filled with instructions, and XOR swap is the name given to this particular section of memory. It's read only because we don't want any modification to be happening to this particular code. Entry is an assembler directive which indicates where exactly execution should start. That is this exact location where you have written start. Okay, because start is nothing but the very first label seen after the entry assembler directive, because of which this is the exact location where execution starts. End indicates the end of source file. There are no errors, so we'll go ahead with debugging. Okay, so at first we have our register R0. Okay, we are loading a value 5 into this particular register, and then we have register R1. To that we are loading a value 10, which is A in hexadecimal. Now we are using XOR operation 3 times so that the value stored in R0 can be moved to R1 and the value stored in R1 can be moved to R0. Okay, what is the general way of doing that? We can use a move operation, use R3, some other register. Okay, move the content of R0 to R3. Then we can move the content of R1 to R0, and finally move the content of R3 into register R1. Okay, this could be a very normal way of shuffling or swapping the contents, okay, of any two register. But in this particular code, we are trying to perform the same swap operation without the usage of an additional register. Okay, so now let's see how exactly it works. At first, we are performing XOR between R0 and R1, and its result is stored in register R0. Let's see what's the result. Is that answer correct? So to check that, let us write the binary equivalents of these values. R0 value is nothing but 5. I can just ignore the higher values because they are all zeros. Okay, and R1 content is 10, which is nothing but 1 0 1 0, and all higher values are zeros. Now if I perform XOR between these two, what's the result? 1 and 0. XOR operation result is 1 1 1 1, because XOR generates a value or output 1 as soon as there are complementary values in the same bit positions. Okay, so the answer generated here is F. That is what is stored in register R0. Okay, next what we are doing is nothing but same operation we are performing, that is R0 content is XORed with R1 and the result is stored in R1, but because of our previous operation R0 is updated as F. Okay, so let's just change the content here. When these two are XORed, what's the result we are getting? It's 1 here, 0 here, 1 here, 0 here. So already as we reach the second step, arg1 is updated with the value of arg0, that is nothing but 5. Let's see if that happens. Yes, and in the last step what exactly is happening? We are performing XOR between arg0 and arg1 itself, but in this particular situation we have arg0 as 1111 itself, that is F itself, but what is arg1? Arg1 is updated with the previous result, which is 5. So let's update it now. And what's the result you obtain for this? 1 and 1. XOR output is 0, 1 0 is 1, 1 1 is 0, and 1 0 is 1. So this is nothing but our initial value 10. Okay, and where is this stored? Into register arg0. So at the end of these 3 steps we have clearly shuffled the 2 values. Now let's see that happening first of all. Okay, so you can see arg0 is now A and arg1 is 5. That was the intention of this particular code. Okay, and now we have jumped into an infinite loop. Now let's understand the logic here. We are considering XOR operation. If you want to perform XOR in ARM, this is nothing but the instruction you use, EOR. Okay, don't write XOR, it will not work. Okay, so now let's see what exactly is happening in the very first step. But before that, let's assume arg0 stores a value A and arg1 stores a value B. Okay, so what is happening here is arg0 will get the answer of arg0 XORed with arg1. But as you can clearly see here, arg0 is A and arg1 is B. So A XORed with B is the result that will be stored in arg0. Now before we go to the next step, what exactly is the new value of arg0? A XORed with B. And what is the value of arg1? It is B. In the second step, what exactly is happening? arg1 is getting the result, as we can see here, of arg0 XORed with arg1. Okay, so what is arg0 here? It is A XORed with B. And what is arg1? It is B. Okay, so this is what we have initially. Now you should know about some of the properties of XOR operation. That is, XOR is always associative. I think this is the term you might have learned in maths, which clearly means this bracket, that is A XOR B XOR B, is equivalent to A XORed with B XOR B. Okay, we have changed position of the bracket and it's still equal because XOR is associative. Okay, so next we need to know about the next property of XOR, which is nothing but self-inverse. That is, B XORed with B is actually 0. So what does that generate? 0. Okay, because this is 0. And next property that you should know about XOR operation is identity. That is, A XORed with 0 is nothing but A. Now what do you mean by B XORed with B is actually 0? If you consider the value of B, what's the answer you will get? You will get it as 0 because only complementary values will generate a value 1. This will be 0. At the same time, what does this A XORed with 0 is A? What does that mean? A XORed with 0. Let's take an example 1 0 1 0 only. When you XOR with 0 0 0 0, what's the answer you get? 0 XORed with 0 is 0, 1 XORed with 0 is 1, 0 with 0 is 0, 1 with 0 is 1. Okay, what is this? This is A itself. Okay, now after all these calculations, what answer have we derived? See, this is where the equation start. So it clearly means arg1 is stored with the value of A. Okay, so arg0 content is already shifted to arg1 in the second step. And what happens in the third step? arg0 was not modified in the previous step, but arg1 was modified. What is the value of arg1? It is A. Now again, when I perform arg0 XORed with arg1, So what exactly will I get here? A XOR B XORed with A. Next, what you should know is nothing but the commutative property, which states that this content is equivalent to writing A XORed with A XOR B. These two are equal because of commutative property. Okay, and here if we check again, due to associative property, we know something like this. Okay, this is 0 because of self inverse. This, when XORed with B, generates a B itself because of identity property. So R0 is stored with the value of B. Okay, so this was the maths behind shuffling the value of R0 and R1 using just XOR operation without the help of any additional registers.